Continuing on stoichiometry, we're going to deal with a problem called limiting reagent. The basics, stoichiometry is a mole ratio. The mole ratios come from a balanced chemical equation, and it is in the shape of an if-then question. However, if you are given amount to start with for all the reagents present, then you have a special type of stoichiometry problem, and this is called a limiting reagent problem. What you need to do is figure out if one reagent will be used up before the others, and once the reagent is used up, the reaction stops. If a reagent is used up first, it is called the limiting reagent, and once the limiting reagent is used up, all of the other reagents are called the excess reagent. Now, to determine if you have a limiting reagent and what the limiting reagent is, there are multiple ways. I'm going to demonstrate what is called the BCA box, where B stands for before, which is the values you are given. C is the change. You are going to do a stoichiometric calculation, and you're going to see what the change is. And then you're going to see what you have left over, if anything, afterwards. There are 6 steps. You need to write out the balanced chemical equation and go from the units you're given into moles, just like before. Then you set up a BCA box. You complete the BCA box and determine if there is a limiting reagent. Then, if there are further stoichiometric calculations to be done, you use the limiting reagent for the if reagent, and then you complete the question. Note, just because a reagent has a larger mass or a reagent has more moles does not mean that it is the excess reagent. The reagent with a larger mass or the larger number of moles can still be the limiting reagent. You have to do the calculations. It's easiest to do this if we have an example. So let's start with this one, where you've got 1.7 moles of nitrogen, 5 moles of hydrogen, and you're going to produce some ammonia. What is the limiting reagent? The first thing you're going to do is write out the balanced chemical equation. And I'd like to put my moles underneath the chemicals. I'm going to do that. I don't know how many moles of ammonia, so I just make that an X. I'm going to convert from units to moles, but we're already in moles, so we don't need to do that. I'm going to set up the BCA box. The B line is the values you're given, so that's for the B. C, the values on this line are going to be stoichiometric. You'll see what that means in a second. So that's the C line. And then the A line is B minus C. So you have the A line. So essentially, setting up the BCA box, just writing the letters BCA. Now you're going to complete the BCA box. You pick one reagent and put that number on the C line. It's the same number as on the B line. I usually pick the first reagent in the equation. So here I'm going to put a 1.75 onto the change line. I'm now going to do a stoichiometric calculation using that value as the if, and the other reagent is the then. If I have 1.75 moles of nitrogen, then how many moles of hydrogen do I have? I do the calculation, and I get 5.25 moles. Now I'm going to subtract C from B and place that value on line A. One of those values should always be 0, and that should be the one that you picked. If the non-zero number is negative, you don't have enough of that reagent, and so it is the limiting reagent. If the non-zero number is positive, then that reagent has more than enough. That's the excess reagent. And as a matter of fact, the value on the A line is the number of moles you have left over. And if both values are 0, you're in the Goldilocks situation. Everything is just right. This is a dichotomous situation. If one reagent is limiting, the other must be the excess reagent. And if one agent is excess, then the other must be limiting. Now, if you have other stoichiometric calculations to do, you use the limiting reagent for the if reagent. So for this example, all further stoichiometry calculations, we use the hydrogen as the if, and then you complete the question. Now, right now, we've answered the question. We've said that the hydrogen is the limiting reagent. But what if the question said how many moles of ammonia should be produced? Now we're in a routine stoichiometry problem, knowing that the limiting reagent is hydrogen, so it will be the if reagent. We know from the question that the ammonia is the then chemical. We set our ratios up and we solve and we get X equals 3.33 moles. There should be 3.33 moles of ammonia made. Another example. Solid aluminum will react with gaseous oxygen to produce aluminum oxide. You've got 4.10 grams of aluminum and 3.84 grams of oxygen. How many grams of the excess reagent will be present after the reaction occurs? Follow the steps. We're going to write out the balanced chemical equation. I like to put my numbers on the equation, and since I'm dealing with grams, I'm going to put it above. Here, since I'm not in moles, I do need to convert. Remember that moles times molecular weight equals grams, which means that moles equals grams divided by molecular weight. When I calculate out the number of moles, I put them below the compounds. I'm going to set up my BCA box, which is just putting down the letters. I'm now going to complete the BCA box, and I put 0.152 because that's the first reagent in the equation, but you could do it with the oxygen. If I have 0.152 moles of aluminum, then how many moles of oxygen do I need? And it turns out I need 0.114 moles of oxygen. I subtract C from B. I get 0 for the first, but the number under oxygen is positive. That means that aluminum is the limiting reagent. And note, the mass of the aluminum is greater and the number of moles is greater. You have to do the calculations out. That means oxygen is the excess reagent. And as a matter of fact, you've got 0.006 moles of oxygen remaining. Use the limiting reagent as your if reagent, but there's no further stoichiometric calculations that need to be done. But you do need to complete the question because it says how many grams of oxygen will be left over. Moles times molecular weight equals grams. At the end of this reaction, you would have 0.192 grams of oxygen left over. Now it's time for you to do one. Propane is going to react with oxygen and form carbon dioxide and water. You put 5 grams of propane in a container with 25 grams of oxygen. You allow the mixture to react. How many grams of water should be produced? Stop, figure it out. I'll give you the answer, then walk you through it. Go. And the answer is 8.15 grams of water should be produced. How did we get that answer? We started by writing out the balanced chemical equation, and I did my usual notation. I then took my grams and converted them to moles, utilizing moles times molecular weight equals grams, or moles equals grams divided by molecular weight, and I start with these values. I set up my BCA box, then I began to complete my BCA box. I'm going to use 0.113 moles of the propane as my if, so I need 0.565 moles of oxygen. I subtract C from B, and I see that I have a positive number under the oxygen, so propane is the limiting reagent. Now I do have more stoichiometry to do, so propane will be my if reagent, and then I will complete the question. So propane is my if, water is my then. The ratio of water to propane is 4 to 1, and that has to equal X over 0.113. When I do my calculations, 0.452 moles of water should be produced. Moles times molecular weight equals grams, so 8.15 grams of water should be produced. So to review, stoichiometry, mole ratios. It can't be stressed enough. Mole ratios come from balanced chemical equations. If you are given amounts for more than one reactant, you now have a limiting reagent problem. The reagent that will be completely used up is called the limiting reagent. The reagent that will have some left over is the excess reagent. And this is a dichotomous relationship. If you have a limiting reagent, then the other must be excess and vice versa. The reagent with a larger number of grams or moles can be the limiting reagent. You have to do the calculations. There are 6 steps for the method I showed you. Write out the balanced chemical equation. Get yourself into moles if need be. Set up the BCA box. Complete the BCA box. Once you know what the limiting reagent is, for any further stoichiometric calculations, use the limiting reagent for the if reagent, and be sure to complete the question that is asked. There is more than one way to solve these problems. If you would like to see them, come see me and we can go through them. You have to use what works for you. And that ends stoichiometry. The upcoming videos will be on chemical reactions.